In this question, we're told the points A and B have coordinates 6, -2 and 4, 1 respectively. The line L1 passes through the point B and is perpendicular to AB. So let's start the question by sketching a scenario. First, I'm going to start by just plotting a point. We're going to call that A, 6, -2. Now I'm going to plot the point B. When I say plot it, I'm just going to sketch it somewhere in relation to the point A. And so the x coordinate is less, so it's going to be to the left of the point, and the y coordinate is more, so it's going to be above the point. So I'm going to put the point B somewhere over here, and there you go, so that's point B, which is 4, 1. Now the second line tells us that the line L1 passes through the point B and is perpendicular to AB. So if I draw the line AB, so AB, and then I'm going to draw the line L1 so that it's perpendicular. Let's include the fact that that's a right angle, and we're going to call that L1. Okay, so let's have a look at the problems we have to solve now with this scenario. So the first part asks us to find the gradient of AB. So using m, the gradient is equal to y2 minus y1, so the difference in y over x2 minus x1 over the difference in x. I'm going to take my rightmost point, which was the point A, as y2, x2. So y2 is -2 and x2 is 6. Take away y1, which is 1, and take away x1, which is 4. So working through this, I get that m is equal to -3 over 2. Part 2 asks to find the equation of L1. So to find the equation of a line, I need a point and a gradient. I have the point B, which is 4, 1. I now need the gradient. I'm going to use the fact that L1 is perpendicular to AB, and so I'm going to use the property m2 equals -1 over m1, where m1 is the gradient of AB. So m2 is equal to -1 over -3 over 2. So this will double negative, we'll turn it into a positive, and flip that fraction upside down, so I get m equals 2/3. So we know that the point is 4, 1, and I'm going to use this gradient and point with y minus y1 equals mx minus x1, so that I get y minus 1 is equal to 2/3 x minus 4. Multiply everything by 3 so that I don't have to work with fractions. I get 3y minus 3 equals, expand the bracket on the right hand side, 2x minus 8. So finally I'm just going to add 3 to both sides of the equation. So I get left with the equation 3y equals 2x minus 5. Okay, let's move on to part B. Part B says the line L2 passes through A and has equation x minus 8y minus 22 equals 0. The lines L1 and L2 intersect at the point C. And we want to show that C has the coordinates -2, -3. So let's just add that back onto our sketch. Here is a line. That's going to be our line L2. So this is our point C, which said passes through the point -2, -3. Okay, so let's go back and show this algebraically now. So solving the equations, the equation I just found of L1 is 3y equals 2x minus 5. We're going to call that equation 1. If we call this equation 2, before I call it equation 2, I'm just going to rearrange it and get x, make x the subject by adding 8y and adding 22 to both sides. So I'll get x equals 8y plus 22. And I call that equation 2. And then I'm just going to state that I'm going to substitute equation 2 into equation 1. Now there should be a method mark for trying to solve these simultaneously, so to communicate please that that is what you're trying to do. So substituting equation 2 into equation 1, I get 3y equals 2 lots of 8y plus 22 minus 5. So expanding out the bracket and collecting terms, I get 3y equals 2 times 8y is 16y, 2 times 22 is 44, minus 5 is 39. So now I'm going to collect all my y terms on one side and the numbers on the other side. So I'm going to subtract 3y from both sides, and I'm going to subtract 39 from both sides, so that we get left with 13y equals minus 39. And then finally I can finish by dividing by 13, which gives me y equals minus 3, which is exactly what I needed here. Finally, let's find x and just confirm this. So substitute this into equation 2 because that's in the form x equals. So I get x equals 8 lots of minus 3 plus 22. So I get minus 24 plus 22 gives me x equals minus 2. So therefore, C is minus 2 minus 3 as required. Okay, so it then says find the coordinates of the midpoint of AC. So the coordinates, if this is part B2, coordinates of the midpoint AC. Midpoint can be found by adding the x coordinates, so x1 plus x2 over 2, and adding the y coordinates, y1 plus y2 over 2. So we're going to get coordinates of AC. The point A was, let's just double check this, 6 minus 2. So we're going to get 6 plus minus 2 over 2. And so then we get minus 2 plus minus 3 over 2. Which when we tidy up, I get 4 over 2, which is 2. And then I get minus 5 over 2, which is minus 2.5. Part 3 says find the area of triangle ABC, simplifying your answer. So if we have a look at the diagram, you can see this is our triangle ABC. And so it's a right angle triangle. So if we do the sides AB multiplied by BC as our base and height, that's how we're going to find the area of the triangle. So part 3, the point, let's list the points that we have here and make sure we've got them all ready. So it's 6 minus 2, and then B is 4, 1. So we've got the 3 points now. The line AB is given as the square root of the difference between x coordinates, so 6 minus 4 squared plus minus 2 minus 1 squared. So when we find this length, we get 2 squared, which is 4, plus 3 squared, which is 9. So I get 4 plus 9 gives me root 13, which is a prime number, so it can't be simplified. If we now find the length of, I believe it was, just double check, BC, so that's the perpendicular side. So if we find BC now, exactly the same way. So we're going to do the square root of the difference between the x coordinates, which is 4 minus minus 2, squared, plus the difference between the y coordinates, which is 1 minus minus 3 squared. And so when I work through this, I get 6 squared plus 4 squared, which is root 52. We can actually simplify that. This has a factor of 4, so I can rewrite that as square root 4 times the square root of 13, which is 2 root 13. So now the area of ABC is given as half times the base. It doesn't matter which one's the base, so let's do 2 root 13 times the height, which is root 13. So the half and the 2 cancel out. Root 13 times root 13 gives us an answer of 13 and that the area is units squared. Okay, so let's have a look and see how the marks were awarded in this question. Although there are no marks for the diagram is really useful and just helps you make sure that you answer the question correctly. So the diagram helped there to identify that we've got the right angled triangle, which sides were going to be my base and height. Part A. There is a method mark for using the increase in y over the increase in x, and an answer mark for getting the correct gradient. There is then a method mark for using the property m2 equals minus 1 over m1, or m1 times m2 is equal to minus 1, and both the same. And then there is a method mark for using the correct method of finding the equation of a line. Finally, if you substituted in the correct values, then you get an answer mark. Okay, so let's look at part B. First of all, the first method mark is an attempt to solve simultaneously. So here's my attempt to solve the equation simultaneously. And then your answer mark is given when you have a convincing argument that leads all the way to having found y and x, the correct y and x values. Part 2 is a method mark for using the midpoint of a line and an answer mark for getting the correct value. Part 3, there is a method mark for using the correct method for the length of a line. There is an answer mark for the length AB, an answer mark for the length BC, and then finally there is a method mark for correct method for trying to find the area of a triangle, so it's going to be half times AB times BC, and then finally an answer mark for the correct answer. Okay, well I hope you was able to follow my solution, and I hope you understood how to mark the question.